Hi, in this video I'm going to be showing you what I learned while trying to put decals on the model of a helmet using DAZ Studio, ArmorPaint and Blender. This is not a tutorial, it's a journey. If you wanna see spot-on instructions, look somewhere else, there's plenty around. If you wanna learn from my mistakes, stay here. Recently on CG Trader I found this model of a motorcycle helmet. The preview pictures show a nice texture painting and the details list pretty high poly count, which could make this a good model for close-up renders. On the downside, there is no UV mapping for this model. Well, I bought it anyways, just to see how to cope with that. In the downloaded files, I find some PNGs used in the material to give the impression of the environment mirroring in the surface. Also included are some images to show how the finished product should look like. And the texture files, which you are supposed to use building the shader. But the most interesting part I can find in the decals folder, which contains these nice looking PNGs with transparency. These are meant to be used as an overlay and must be applied as a decal. As I plan to render within DAZ Studio, I need to create a DAZ compatible prop from this model. So my first approach is to load the OBJ file in DAZ and somehow apply the PNGs to the surface, since DAZ has a decal function called Iray decal node. Importing a foreign mesh is always kind of a try and error hitting the right scale and orientation factors. But for my first try, I don't care. The OpenGL preview renders the helmet mostly black with some colored parts. This color information comes from the material file, which contains a list of parameters for each material of the object. There is no mesh data in it, only information for the shader. But it's nice to have a look on it, since it also refers to texture files which might be missing in the downloaded package. DAZ Studio lists the object's materials under the Surface tab. The material I am interested in most is the one assigned to the shell of the helmet. It's called Paint Enamel Black. This is the material the decals are to apply on. However, for using the Iray decal node, this is of no relevance because it does project the decal onto the mesh in no regard of the material. I add a decal node to the scene by opening the Create menu and choosing New Iray decal node. After accepting the default name, DAZ Studio adds an Iray decal node to the scene graph. Even though the decal node does not contain its own geometry, it has a material. And the material has a base color for which I select an image map. And that image map happens to be one of the decals that came with the model. With the image applied to the decal node's base color, I expect the node to project the image onto the helmet's mesh. But even after desperately aligning the node's bounding box, this does not happen. Well, first it's an Iray node, hence it only works in Iray, so I have to use the Iray preview mode. And after it stubbornly refuses to work even in the Iray preview, I finally realized that the node is in the wrong hierarchy level. You see, it only works when it is located as a child node of the helmet. Only then it knows on which geometry it has to project its content. So I drop the decal node onto the helmet's node, et voila! The decal shows up on the surface of the helmet. Although not in the right orientation. This is something which is easy to fix, since the Iray decal node has an orientation in 3D space which can be changed. As well as the location and the scale. Being a brute force renderer, Iray is very slow. Well, these are the moments when a decent graphics card comes in handy. So this could be one method to put textures onto the helmet, but I don't want to create an asset with all the nodes complicating the structure within DAZ Studio. I want a proper image map containing all decals. The use of an image map requires a proper UV map, and the CG Trader's product page already told me there is none. Let's check that. Although unfortunately DAZ Studio can't edit UV maps, it at least has a viewer. With a model like this, I want to select the surface first and then switch the viewport to UV view in the view selection menu. DAZ Studio shows me the UV map of the selected surface. What a mess! I check if the viewer really shows the UV map by material, since it also can show the map by node. The latter would display all parts of the map in one view. By switching through the different materials, I can view all the parts defined in the map. What I see does not look like an unwrapped map at all. So I have to unwrap the UV first, and this is a task which I can do in Blender. In Blender, I import the OBJ file by going to File, Import, Wavefront OBJ. Before I hit the Import button, I take care of the model's orientation. In DAZ Studio, the helmet stood with the bottom opening sideways, so I select Z up in the Transform section of the Import dialog. The orientation is still not perfect, since it now faces back to front, but I don't care. By switching to the UV editing workspace, I get a split screen and access to the UV tools in Blender. After switching the right viewport to the edit mode, I can select the mesh, and the left side shows the corresponding UV mapping. This is of course the same mess I just saw in DAZ Studio, but Blender offers a nice function called Smart UV Project. This magically creates a nice looking UV map, but is it really good? We will see. I have to export the model as OBJ again in order to be able to import it in DAZ Studio or ArmorPaint. I'm always struggling with my folder structure. This is hands down the hardest part, trust me. Now with this done, let's head over to ArmorPaint and continue the journey. Before I import the OBJ I just saved in Blender, I want to show you briefly what ArmorPaint is and how it works. Well, with ArmorPaint you can literally paint directly on a 3D model. You can use different brushes and define your own materials like I do here, very rudimentary, by just changing the color. The fascinating thing about that is it automatically creates the picture for the UV map. So it simultaneously paints in the 2D domain and your brush strokes follow the unwrapped mesh in the UV window. Now let's try that on the helmet, shall we? For demonstration purposes, I load the unwrapped OBJ first, so I can show the problems with it. Furthermore, I do not choose any import options, which is also not a good idea, as we will see. There is the helmet in all its glory, and I can paint on it with my blue color. But see what happens. It weirdly paints also different spots at the same time. This is because the UV map is not unwrapped and is organized in a bad manner. It looks chaotic and we have overlapping segments, or islands as they are called. In my next attempt, I load the OBJ with the unwrapped UV map. Again, with no import option. Now my painting is clean without any duplicate strokes. On the 2D view, I can see that my painting gets automatically distributed all over the place, exactly according to the mapping of the mesh. I can paint across all of the model. That's a problem, and I'm gonna be showing you why. Just painting is nice, but in the end I will have to apply a decal, which is basically one big brush. So I switch to the Decal tool. The decal is now attached to the cursor. No worries, I will show you how to create a decal in just a couple of minutes. I can apply the decal to the model wherever I want with one click. Now this works fine on the side, but watch what happens if I want to apply it scaled to the right size on the top. Let me quickly bring in the reference image. Bear with me, at that time I hadn't figured out how to rotate properly. Screw it, let's apply it anyways. There is a slider on the top left corner for resizing the decal under the cursor. I also didn't know that you can easily resize with your mouse wheel while pressing the key F. Applied, and now compare the result with the reference. Right, the decal goes over that vent plastic part, while in the reference it's beneath it. Now I have to find a way to apply the decal only to the parts I want. That paint enamel black mesh would be a good idea, right? Well, technically speaking, paint enamel black is not a mesh, it's a material. But the material is assigned to some faces of the helmet's mesh. Therefore, you can select those faces having a particular material assigned to it. And the gentleman who created ArmorPaint, yes, it's only one guy as far as I know, makes a clever use of that. So now let's load the OBJ again, but this time we tweak our options. As you can see in the dialog, there is a drop-down called Split By. By default, ArmorPaint splits by object. I select Split by Material. Now I'm ready to import. On the first glance, nothing's changed. I still can paint on anything I want, but there is a small difference. In my layer settings, I can select the part of the model the layer refers to. I told ArmorPaint to split the model by material, hence I can see a list of materials here. I select Paint Enamel Black. When I now paint on my helmet, the blue color only sticks to the faces of the model being assigned to the material Paint Enamel Black. Of course, this also gets reflected in the UV map. But wait, there is a pitfall. Look, what? I can still paint on that vent plastic thingy? To figure out why that is, we better switch back to Blender. I bet that has something to do with the material assignment. Back in Blender, I make sure that I have my model selected. It is, because it has that orange outline. On the right side selection, I select the Material Properties panels, and I get a list of the helmet's materials. When I click on Paint Enamel Black, nothing happens because I have to be in edit mode for material assignment. Switching over to edit mode also changes my options in the Material Properties panel. I have an Assign, a Select and a Deselect button. With Paint Enamel Black selected, I click the Select button and Blender highlights the portion of the mesh having that material assigned to. And here we can see our problem. Paint Enamel Black also includes all the vent plastics attached to the helmet's shell. The other materials do not seem to be troublemakers. We have a little red lever, a couple of black rubber parts, and something called Lambert, which is the inner padding. The creator of the model intended the meshes inside the vent openings to be of the same material. Now let's fix our material assignment problem. It's easy. Even though it's not necessary, I change the selection mode to face. Then I select one face of the helmet's feature I want to change the material for. In the Edit Modes Select menu, I go to Select Linked and choose Linked. This can also be achieved by using the shortcut Ctrl+L that selects all faces belonging to the vent plastics. How does Blender know that? Well, this was done by the artist during the creation of the helmet, mostly automatically supported by the modeling software. The OBJ file keeps that information. I want to create a dedicated material for all the plastic parts. In the Materials Properties panel next to the material list there is this plus button. After hitting this, Blender creates a new material slot. Because this is only a slot and not the material itself, I have to fill the slot with a material. Since I don't have one, I create a new one by clicking the New button beneath the box. Blender creates a new default material named Material 001 and fills the slot with it. I'm not happy with that name because I need to find the material in other applications such as DAZ Studio as well, so I choose a descriptive name for it. Plastic Black will do it. Wait, with an underscore. Now that I have a material and the part of the mesh selected, I can assign the plastic vent to the slot by hitting the Assign button. The vent goes white because it now has the newly created material assigned to it. I don't care for the properties and the look of the material in Blender. In DAZ Studio I'm gonna be using Iray, hence I have to reassign the materials anyways. The other things I'm doing to the model are pretty much the same. It's just assigning materials. I won't bore you with that. Again, back in ArmorPaint. Again, importing, and again making sure that it is split by materials. In the layers list of materials, I now can see all the new materials previously created in Blender. I choose, of course, Paint Enamel Black again, and I already can see that this time it looks different to my last attempt. My painting does not affect the vent anymore. Actually all vents, because I sand a lot more plastic parts than just the top scoop. So finally the helmet is ready for the decals. At least that's what I thought. In one of my previous attempts I already noticed a weird behavior that prevents you from painting a surface. Let me select the black rubber parts first. Now it's obvious that I can't paint on the shell anymore. But if I want to paint the rubber gasket on the bottom, which has that rubber black 001 material assigned, it doesn't work either, sort of. See, I can paint on the inner side, but the more important outside of the gasket doesn't seem to take any paint. Also, it has that weird half-transparent look to it. Let's try and flood fill it with green. The same in green. Wait, solid on the inner side, transparent on the outer side. Something's flipped. Let's check it in Blender. Here is our helmet, and forget about the red lines on it. I only want to show you what normals are and how to flip them. As you can see, the helmet's mesh is made up from a lot of faces. Naturally, those faces have an inner side and an outer side. In my common sense, I would say that I'm currently looking upon the outer side of the faces. From the geometry lessons at school, we know that the orientation of a plane in the 3D space is determined by a vector. This vector is called the normal vector and is standing orthogonally on a plane. That means it has only right angles to the plane. Those nitpicking mathematicians tell us that there are actually two vectors, because if you flip n1 around, you would end up with the plane having the same orientation in the 3D space. But in 3D applications, we use only one, and if it pokes into your eyes, you are looking right onto the face. Because this is such an important concept, Blender has an option to make that visible. The controls for the 3D viewport offer a menu which is called Overlays. In that menu, I can control which additional information the viewport displays on top of the 3D objects. I can switch on and off the 3D cursor, show or hide seams and sharps, and I can make the normal vectors visible. Apart from the sensation that now my helmet looks like a hairy ball, I also get the information which faces look inwards and which outwards. Each face has a little line attached to it, which is pointing outwards. By that I know that I don't have a problem with the helmet's shell in that respect. But when I look at the rubber gasket on the bottom, it seems the little lines are disappearing towards the top end of the gasket. The only reason that there are lines at all in that area is that there is geometry beneath it, which normals poke through the gasket. This becomes much clearer if I hide the irritating parts. See, no lines on the gasket. But if I navigate inside, here they are. The faces are looking inwards, and that's why I couldn't paint on it. Also, some shaders have a problem with that, some don't, so better flip them outwards. Fortunately, this is a very simple operation in Blender. Like I've done it before, I select just one face and hit Ctrl L to select the whole gasket. Then I right-click the selected mesh to bring up the context menu. There I go to Mesh Tools. The Mesh Tools submenu has an entry called Flip Normals. Clicking that might cause Blender to think for a second, but the result is obvious. The normals are pointing outwards this time. And while I'm at it, I correct some other meshes as well. With these corrections done and saved in the OBJ, I'm ready for my next iteration in ArmorPaint. Is it the final iteration? We will see. Hello and welcome to ArmorPaint again. If you came here for a tutorial in texturing with decals in ArmorPaint, this is your money shot. I already loaded the helmet with split materials, and before I apply decals to all of its sides, I make my life easier by setting up the camera view. In the camera menu, I switch from perspective to orthographic view. This will help me precisely placing the overlays. In the meanwhile, I also learned how to rotate the camera. It's the number block on the keyboard, like in Blender. I'll start with the top decal. First, I need a new layer. And yes, it's a paint layer. I didn't get along with the decal layer. I don't need its features. My images are already rotated properly and I need also mirroring. Although it's not necessary, I rename the layer to the name of the decal just for the better looks of it. I want to apply the image on the helmet shell, so I select Paint Enamel Black in the layer properties. Just for the purpose of demonstration, I select the same also for layer 1, so the excluded parts show up in black. I make sure that the decal top layer is selected, and then I head over to the bottom area of ArmorPaint. There, under the tab Textures, is an import button which allows me to import my decal image. My imported decal image shows up in the ArmorPaint's texture gallery and is ready for use in a material. In order to use my texture in a material, I create a new one by clicking on New in the ArmorPaint's Materials tab. This creates a new material with the default settings. By double-clicking the material, ArmorPaint opens the material editor, which is node-based, just like the one in Blender. The default material's base color property is connected to an RGB source, which I have to replace by the texture. I select the RGB node, hit delete, and it's gone. Before I forget it, I rename the material to something like the decal's name, because I can. Then I drag the texture icon from the gallery into the material editor, which creates an image texture node. The image texture node has two output parameters, color and alpha. These I connect to the inputs for base color and opacity of the material output node. Note that the texture image shows up as an icon for the material in the material gallery. With the material selected, I change the brush tool to the decal tool and the decal image gets attached to my cursor. By rotating the mouse wheel while keeping my keyboard's F key pressed, I can adjust the size of the decal. Since I don't know if there's any alignment tools in ArmorPaint, this requires a good eye and some commitment. If I had used a decal layer, I would have been allowed to adjust the layer with the decal applied, but it also works without. And boom, applied. Next is the decal for the sides. I use the same procedure to import the texture and create a material. It doesn't matter if I create the material first or the layer first. I could even paint all decals on the same layer. But if I want to individually delete or repaint decals, it's better to put each decal on its own layer. The decals on the side are special because they use the same texture image but mirrored on the other side. At that moment, I nearly missed the fact that ArmorPaint provides a function for this. In the tool settings on the top of the 3D window, there are checkboxes for symmetry. I check the symmetry for the x-axis. And now I apply the decal. ArmorPaint will automatically apply it on the other side of the helmet as well. I think this is an exciting function, and I immediately verify the result. Indeed, it worked. Wow, I'm impressed. That saved some labor. While I repeat these steps for the rest of the decals, I want to tell you that you can do all of that inside Blender as well. There is no need for an extra tool, but the workflow doesn't even come close to the smoothness and convenience ArmorPaint offers. ArmorPaint comes in two versions. You can download the sources on GitHub for free and compile it yourself, yikes, or download it as an executable for Windows, Linux or Mac from Gunrod. They charged me €16 for that, and I must say, it's well worth it. After having applied all the graphics on my helmet, I have to save my project. Under File, Save As, I can save the ArmorPaint project file, which contains all the layers and materials I defined. This is only to edit my project in the future. If I want to use the outcome of my texturing, I have to export the images. I go to File, Export Textures, which opens the export dialog. Here I can set some parameters such as format, color depth, and most important, the resolution. I set the resolution to 4K, of which I think is a good mid-quality option for rendering in DAZ Studio. I click on Export and select the dedicated texture folder I had previously created. And of course, I'm interested in the actual output of that export. How does it look? Well, pretty convoluted, isn't it? But no worries, ArmorPaint created exactly the geometry we need for applying this as a base color map in Iray. In DAZ Studio, I import my helmet first, make sure it's selected that I can see the list of materials in the Surfaces tab. There, I select the Paint Enamel Black material, and in the controller for the base color there is this puny little icon next to the overdimensioned color selector. That icon allows me to select the image map for this surface. After the import of the image map, I can't see anything different on the helmet. It appears black like before, and that is because the base color is still set to black. So I change it to white, and look at that, here it is, all the schmick decals right where they belong. And the cool thing about it, there is no subnodes, only one prop with an image map. Let's inspect it in Iray. That's not what I call exhilarating. It's so coarse. That's not what I want for a close-up render. Did I do something wrong? Yes, I did. To explain what I found out, I'll fire up Blender again. The last time for now, I promise. Now, if we watch our unwrapped UV carefully, we notice that the actual shell of the helmet only occupies a very small portion of the available space. Consequently, it's obvious that if we set up our 4K resolution for the whole map in ArmorPaint, which is 4096 by 4096 after all, the actual outcome of the Paint Enamel Black portion is only a fraction of that. And no, it's not our decals, cause they already have a whopping 8K resolution. So what am I supposed to do now? I could increase the resolution of the image map to galactic dimensions, but that is totally impractical. By the way, my attempt to export a 16K map in ArmorPaint failed already. No, I need to rearrange my UV map in a way that the helmet's outer shell takes up more space. To achieve this, I'm gonna unwrap the shell separately. In a first attempt, I do not use Smart Project, and as a result, I get this. UV islands like this are not a problem per se. ArmorPaint will process those correctly, no worries. But the density is not distributed well over the UV space. To show you around, I synchronize the two windows in Blender. Whatever I select on the right will show up highlighted on the left. On the forehead, the density is fairly low, therefore my image map has a high resolution, relatively to the overall resolution. But if I take samples on the top of the shell, I end up in a much denser area. Therefore, my resolution decreases in relation to the size of the image map, and the end product will have that pixelated look. Therefore, Even though ArmorPaint does a very good job, it is a good idea to put more effort into the UV unwrapping. UV unwrapping is a science in itself, and you could write books about it, but the folks from Blender tried to make it easier for us. They implemented the function Smart UV Project. This algorithm tries to project the mesh onto a viewing plane, but breaks the projection up as soon as a certain angle to the plane is reached. Then it continues projecting from a different viewing angle, again breaking as soon as the angle is about to exceed the limit. This maximum breakup angle, that's my terminology, don't quote me, can be configured in the Smart UV Project dialog. It's nice to experiment with, but this time I'll keep it as it is. You see, because of the complicated shape, the algorithm found the angle exceeding multiple times, and each time it created a new island. That might be annoying in some cases, but at least the density is distributed more evenly. We can even improve the unwrapping by doing it manually, and regarding this I'm still a noob, so don't scream at me if you know more about that. Instead of letting Blender find the edges where to slice the mesh on its own, I can provide this information by creating seams. To create a seam, I first switch to edge selection mode and mark an edge where it naturally occurs to me that the geometry has a break in continuity. To find all the subsequent edges for my cut, I use the Edge Loop tool. It's under the menu Select Loops, Edge Loop. I created my own shortcut for this, so you can't see me clicking the menu. Blender selects the loop, which only continues until there is a break in the mesh topology. For instance, it hits the edge of the mesh. Finally, I create the seam by clicking Mark Seam in the context menu. Blender marks the seam with a red line. I add a couple more seams until I have the impression that the mesh might be divided into suited parts. Bear in mind that placing seams is also an artistic decision, since they might be visible in the render, especially if a texture with a very distinct structure gets applied. As you can see here, Blender does not always find the loop completely by itself. Sometimes it needs a little help to find the right path. After having finished marking all my seams, I hit UV Unwrap. No need for Smart Project this time. The result is still not totally even regarding density, but good enough for me. One last time I have to head over to ArmorPaint. Because the UV map has changed, I have to do the texturing again. And I'll show you one more of my pitfalls. At my first steps in ArmorPaint, I didn't realize that each layer can have its own resolution. The default resolution is set to 2K. I plan to export an 8K texture map, so I set my layers also to 8K. The rest of the operations in ArmorPaint are just like you've seen it already. Just one small side note before I switch over to DAZ Studio for the end result. Off camera, I did change the color of the layer 1 to a dark tone. Layer 1 is on the bottom of the list, therefore it's in the background and all the other layers stack on top. If the decal should overlap, I could change the order by changing the order of the layers. So, ready for the final inspection? Yep, I think that's acceptable. So there you have it. That was my journey across texturing with decals in ArmorPaint, with a lot of Blender in it. Although it's still a lot of work, it at least is no mystery anymore. And like it is with so many other mysteries in the 3D arts, don't be scared. Just do it.